السلام عليكم قطابياني خوشيست دوباره قرانا ولاتن بواني تشيني لا واني يورا we will talk about electric field Basha. So what is electric field and what does it represent and how can we determine or find the magnitude electric field and all that Basha. So the first thing that we're going to start with is the definition of electric field. What is electric field? We can say electric field or Gutman or electric charge. It is a field force, yani it can attract or repel even without a direct contact. So the reason why it can attract or repel even at a distance, that is because of electrical field here. What is electric field? It's whether positive or negative. A region around this electrical charge where electrical force can be detected, that is called the electrical field in general. Just for example, like a farmhouse, it has a fence. Anything inside, farmhouse, anything inside the fence, it belongs to this charge. So we can say this is the electrical field around this. But what exactly, like if we dive a little bit deeper into this, into the details of this, we can say electric field, Basha, it is a region around the charge where electric force on a test charge will be detected. What exactly do we do this? حتى بزانين electric field اشتكانكو strength اشتانكو بابا charge بكاردينين وكو test باشا. So this is called a test charge. طبعا charge or test charge it is always positive. Scientists used to use this one. قبل ما وصلوا negative they of course they had to use one of the charges whether positive or negative. So they decided to use a positive charge as a test charge, but test charge it is a bubbling, it has a small value. If we place a test charge here, you'll see that of course now these two are going to repel one another. This test charge, because it is smaller, it will be repelled by this charge in here. What if you place a little bit further here? It is still repelled but if you place it somewhere here, so at this point it can no longer affect this test charge at this point here. So this is the test charge here. So based on this, as long as there is a force on a test charge, so we can say that this is inside the electrical field. And I get to my test charge within here, the positivity here, it is going to repel one. So if this is a test charge here, these two are going to repel one another. And now test charge it is going to move away. According to this, the 20 blend, the direction of the direction of, we can say, electrical field for a positive charge, it is going to be outward. Basha, it is going to be outward. So that of course we have a nice field here. Of course you could draw more of them, but try to have equal spaces between any of these charges. This region around a charge where electrical force, Basha, on a test charge can be detected, that is this region here, it is called the electric field. Basha, symbol electric field, baba, it is E. Basha, what the electric field, Basha, it's a field around a charge. Command symbol K, it is. We'll use E for electric field. Basha. So Basha. Good man. What if it is like a negative charge? What does it look like? I get positive beaten. Good man, force they're going to repel. The direction is that magnetic the electric field that has both magnitude and direction. Direction can could be no. Good man, test charges didn't Basha. So if these two are positive, so you can see that these two are going to repel. This positive charge is going to repel this positive test charge. The direction of the electrical field for positive charge, we can say it is outward. What if it is a negative charge? Negative charge, it should be in test charge. Right? It's positive still, that is going to be attracted to the negative one. It is going to be attracted. It is going to be attracted. According to this, we can say that if it is the direction of electric field, if it is positive, it is outward. If it is negative, it is inward. Or direction based on this positive test charge. All right, we can say this is the electric field for we can say electrical for electrical charges. Basha. We can find the magnitude of the electrical field. Magnitude electric field the electrical force because there will be a force on the test charge. The electrical force divided by what? We can say divided by a charge. You can call this one test charge as well. That would be totally fine. This would be the electrical field. Astaka, that one in the unity electric field it's here. Unity electric force, it is Newton. Unity charge, it is Coulomb. So we can say the unit of electrical field, it is Newton per Coulomb. So the SI unit of electrical field, that is Newton per Coulomb. If I ask you, what does it depend on? You can see that it depends on the electrical force on the charge of bubbling, the charge on the charge. So of course, bubbling, the magnitude of the charge, that would be what it depends on. And you can see that is directly proportional to the force when so the stronger the force, we can say, or the stronger the electrical force, that means the more the electrical field. An electrical field, there is a region where an electric force on a test charge can be detected, can be felt, can be measured, and it is measured in Newton per Coulomb. Good man. I get the positive baba. Good man. A small charge here, it is called the test charge. Now, because it's repelled outwardly, it is inward. Basha. That would be for that. Good man, electrical force like gravitational force, it is a field force or that it can attract or repel even without a contact. Field force explains how there's nothing much in here. Basha, that one electric field strength, Basha, it is defined as the electric force on a small positive charge divided by a charge measured in Newton Coulomb. Equation Ibzana. The electric field is a vector quantity that has both magnitude and direction. For a positive charge, the fill line pointing away. If it is a negative charge, the fill line points toward the charge. What exactly happens if we get electric field? Electric field, let's change this color here. Electric field, electric field an electric field electric force divided by a charge so when electric force K Coulomb's constant, that one below Q1, Q2, these are the two charges, divide by the square of the distance between the two, and also divide by this charge. Just that one charge will cancel out with the other charge. So what is left now? We can say electric field, it is equal to Coulomb's constant, the charge divided by what? Divided by the square of the distance, Basha. At this point here, we have two equations for electric field, Baba. Yakachandalan electric force. Let me rewrite this one. The two equations we have now, these are this. Electric field, the electric force divided by the charge, Basha. And then the second equation, we can say electric field, the K for Coulomb's constant, charge divided by the square of the distance. Equation equation do force use this one. I get distance to charge Basha. had distance دي أكثر equation دوام بكاربين بس قال لي بالهيرة according to this equation what does the electric field strength depends on بابا we can say depends on two things when it's constant عادة حسابي لنا كده because it is fixed باشا that depends on the charge باشا and also it depends on the distance يعني بابا the square of the distance for let's say from the charge or how far we want to measure the electric field from that charge. That would be the strength of electric field depending on Basha. قاعد لدو خالي ببابا وأبشارش من هي قاعد لي بدلو what does the strength of electric field depends on at a point. It depends on the charge. The greater the charge producing the field, the stronger the field. Where the distance or the field strength decreases with the square of the distance. Square of the distance, this is the inverse square law. Distance to do on that field it decreases by 4 times. The field becomes 1/4. And decrease 4 times and 1/4 is the same thing. But what if the distance becomes half? Field increases by 4 times. طبعا بسارة باشمان هي اللي صار this electric field strength باشا. And that of course let's solve this question together. An electric field electric field كمان هي زور باشا electric field كمان هي let's send that. It is 2 times 10 to the power 4 Newton per Coulomb. This is electric field. It says directed along the positive x-axis. At this point here, we can say that we have an electrical field بس direction أو electric field day it is towards X positive باشا. This is what it is. يعني you could say that this is the same as if it is that's the electric field strength باشا directed along positive X axis. What is the electric force on an electron in this field here? What is going to be the strength of an electric force on this electron? And then we know that even if you look at this one here, this side, for example, if this side, you can consider this to be positive because it's the same as if it is radiating outward. On the other side, of course, you can consider this there is something negative because that's how it is. When you got that at this point here, we can see that if it is moving away from a positive awkati the twin blend, if you want to move this electron in the same direction as this one, you have to force that because on the other side, you can see that there's a negative there. All right, so this of course going to repel the twin blade in order to move the electron away from a positive charge. You need a force. بس أنا أرزم شتشي now أنا واسنا أنا بينك كأسي خد في مشينا. What is the electric force on an electron in this field here? بس قاعد لي بقول مع electric field direction magnitude هي كدلا electron قاعد لي negative electron كيبيتن. قاعد دلا electric field باشا strength that قاعد say but man because we have the electric field, all right, and it asks us about the force. Which equation do we use? We're going to use the first equation. Electric force divided by the charge. Let charge electron. We can cross multiply, of course, to find the electric force on an electron here. The line electric force. The electric field times charge electron. At this point here, electric field command sender that is 2 times 10 to the power positive 4 times charge electroni again leave it's negative 1.6 times 10 to the power times 10 to the power negative 19 basha. So once you do the math, of course, you will find the electric force on that, which is going to be negative 3.2 times 10 to the power negative 15 Newton. Or negative and this force that has, or there is a force that must be acting opposite to the direction of, what is it called? To where this electron is naturally flowing. Let's just call it that way. Basha, kata force has to be, where the force is going to be negative 3.2 times 10 to the power negative 5 at this point right here. Basha? All right, that is for the electron. That is for part A. Basha, what is the second part? We can say, the question says, what is the electric force on a proton in this field? Basha? So what is the electric force on a proton here? So if we have a proton now, that's going to be the same thing, only proton is positive. When you got an electric field, Basha, an electric force right away. The kata say electric force, but man, the kata electric field times the charge of a proton. So at this point here, Gutman, this is 2 times 10 to the power 4 times charge protoni baba. It is positive 1.6 times 10 to the power negative 19 coulomb. But this time is going to be positive 3.2 times 10 to the power negative 15 Newton. That is the electric force on a proton inside a field. Katagar protonic bablin protonic man habu on the force lesser debit nagar electronic bu on the force lesser debitan and that will be it. Or you could say the other way, actually, regarding this negative here, you could say that this electron will be attracted to the negative side. This would be better, actually, Basha. But if it is proton, of course, that is going to move to the positive X, Basha. The reason why we get this negative, Basha, that means there is a force that is trying to move the electron to the negative side, and Babylon to the left side, so it becomes negative. But Zawedi proton K, it is going to push to the positive side because it is going to move the same way. أوقاتي دبيتا positive. أو بالنسبة له برسالة كانت directed towards the negative x-axis أو يديك عشان directed towards the positive x-axis. Electric field line man هي بابا بيشتري بس ماكد ونيا قلت man there are or these electric field line that we draw them أو field دانيك we draw them around these positive or negative charges بابا. These are not real field lines. If you have a balloon that is positively charged, do you see any lines around? He's line very well on of course no. When yeah. So what are these lines, Kaka? These are visual aids to see how the electric field strength is, or the direction of the electric field strength. What does these lines represent, Kaka? Maybe these two lines were Babylon. These lines represent two things, Basha, and these are the magnitude of the electric field and also the direction of the electric field. Kata, imagine or consider, Basha, we have two charges. One of them, Basha, one of them has only, let's say, two lines. Or let's make a four line, this positive one, yeah. And then there is another charge that has so many lines here. All right, so what can you say about the magnetic, the magnitude of the magnetic field, the electric field of this charge? Clearly, more lines, that means stronger electrical field. Less line, weaker electrical field. If it is outward, that was the first. If the second thing, the second point, if the line is pointing away, that means it's positive. Kata direction electric field. Okay, when yeah. If it is inward, kati the beta negative, and and that will be the field of a negative charge. Here. For example, if we have two charges here, let's say Q1 and then Q2, Basha. So we could have something like this, Q1, Q2. Let's say we have four lines here, okay? And then here we have, let's just say these are, that is 4, 5, 6, 7, and 8. Is that, if I ask you, what is the ratio of Q1 to Q2, what would you say? How do you find ratio? Ratio, yani, division, a fraction, when you ratio Q1 over Q2 here. Q1 is that. Man, how do we know how many ratio? I would just count the number of lines. That is going to be 1, 2. This counterclockwise, but still 1, 2, 3, and 4. So I have 4 lines. You could just write 4. What about this one here? You could start counting here. It is going to be 8 lines. When you got that 4 divided by 8, we can say 1 over 2. And yeah, that is going to be, so the ratio is 1 over 2 here. Pasha? Now, according to these lines, what are the polarity of these charges? Are these charges positive, negative? What are they? Because these lines are outward, so this charge must be positive. Our charge it is inward, so it has to be negative. لو خالنا هي بيخربني كاتا بتمان electric field line بابا أو لو خطان like electric field lines Basha, these are lines that represent both magnitude and also the direction of what? Of the electric field. These are not realistic. These are just visual aids to help you understand better. I get a positive view. The field line is radiated outward, Basha, infinitely. If it is negative, it is inward. Taban, because these lines are either going outward or going inward from infinity. These lines do not cross. Why? Because the further they go, especially if it is positive. If it is positive, let's say, the further it goes, the more and more they separate from one another. But if it is negative, they come from infinity and then until they get close to the charge without ever, let's say, intersecting. We also know that the field strength increases near the charge, consistent with what? With electric field that is inversely with the square of the two. It becomes stronger, but if you move away from the charge, field strength bow relationally. Electric field lines never cross out. concept conductors in we can say electrostatic equilibrium. And these are electric field lines. Electric field line if you've noticed, we always draw them outside the object. And by the way, they always have to be perpendicular to the surface of to the surface as well. Like once we draw them perpendicular. Like you cannot draw them something like this because that'll be wrong. Okay, so the next thing that we have, these electrical field lines only they extend on, let's say, outer side of the of the charge. We can say there is zero electrical field inside the objects. Inside the object, there is no electrical field. Our electric field object on the surface, and we can say outward. Heats line now surface surface or conductorenia. When we say conductor, we mean an isolated conductor. Or conductor heats connect نبوة بابلانوسفيريا heats connect to shidnia كاتا قلت man there is no field inside the object and field like a 0 the field is only distributing outside of the surface and دەتوانین بڵێن هەتا ژمارە یان با بڵێن سرفەسەکە گەورەتر بێت تاوان دەتوانین بڵێن ژمارەی لاینەکانیش دەکرێت زیاتر بێ بەس خاڵەکی دیکەشمانەیە کە زۆر گرنگە and that is this. But man, for regular objects, the electrical field line, they distribute equally, Basha. But if it is irregular object, for example, like a sharp object here, for example, something like this one, yeah, it doesn't matter, whatever the object is. Okay, let's just say this guy, all right? So at sharper edges here, there would be more electrical field line. But the charges kaka tend to accumulate more. Basha charge can زيادة لو شو أنا خرد بنوع كوا بابلن شويني sharpen. Basha, they have a small curvature, and of course, because of that, there will be more electrical field line compared to any other points you could say. Basha, كواتا قاعد لي بيلشنا sharp كان electric field line زياتري ليه بي أدو خالد توان بلن يكم متسارم لهم يقرن ترى بتمان electric field is zero everywhere inside the conductor أو زوزو قرنجا any excess كواتا هر charger شيء زيادة ما نهبي تنسر conductor كي it would be of course on the surface of the conductor. Basha, or you can say outer surface. The electric field just outside, let's say field just outside a charge conductor is perpendicular to the conductor surface. So Basyaman Kadania Gutman line can be perpendicular ben Khali Taram on an irregularly shaped object. Agar shape man have irregular bu Saina Bashayan. Aukati the charge tend to accumulate Basha, where the radius of the curvature is the smallest. And in other words, we can say at sharp points. Section review. I would like to solve this question for you. Well, find the electric field at a midpoint. Midpoint it is there's a keyword here between two charges. It is 40 times 10 to the power negative 9 coulomb. And then the second charge is going to be what? Q2 dakata 60 times 10 to the power negative 9 coulomb, separated by a distance of 30 centimeter. Distance it is in centimeter, we have to convert that. So if I want to draw the two charges for you, that would be charge 1 and this is charge 2, we could say Basha. So Q1 and Q2. These are separated by a distance, distance 30 centimeter. But specific the electric field find electric field E at a midpoint, right in between the two. If it says right in between the two, right now in the kebab that a midpoint in between the two. That is going to be right at this point. So what is half of 30 centimeters? Is going to be 15 centimeter one, yeah. But we want you to convert 15 centimeter to meter. How do you do that? Just divide by 100, you will get 0.15 meter. Basha. This would be the distance from each charges here. This side is 0.15 meter, like 0.15 meter. But I got electric field and these are both positive charges. That is positive 40, this is positive 60. And we know that if it is positive charge, the direction of the electric field that is going to be outward. For this one is also going to be outward as well. Kata, what do you think will happen now? At the end, we'll have to find the total electric field right at this point. And because these two electric fields are in opposite direction, we have to subtract them. And clearly, which charge is stronger? You can say bigger. Charge 2, of course, has a bigger magnitude. Kata, magnetic field dy must dominate, must be overcoming this one here. But first, I'm going to do equation here for electric field. The first one we said electric force divided by the charge one, yeah. And then the second equation for electric field, it is K, which is Coulomb's constant, charge divided by what? By the square of the distance from that charge, we can say. Basha Kawata. We have these two equations. Now, at this point, which one of these equations do we have to use at this point here? Of course, the second one, because we have the charge on the distance. This is the equation that we have to use. But the electric field, the charge the midpoint or right at that point here. First of all, let's find the electric field of charge 1. So how do we do that? You could write the givens one if you want to. 40 times 10 to the power negative 9 coulomb. Q2 dakata 60 times 10 to the power negative 9 coulomb. Distance بيني and 30 centimeter. قال لي كاتا the distance between each one of them is 50 و k coulomb constant اللي بيدنتي باشا كذا كاتا تسند كاتا 8.99 times 10 to the power positive 9 good man دكاتتي أو دكاتة Newton we can say meter square لسر coulomb square باشا أقعد constant أنا بكاتا. The first one, let's find electric or magnitude of electric field for the first charge. Good man. We'll use the second equation باشا. K دكاتة charge over the distance squared in here. كاتا coulomb's constant good man 8.99 times 10 to the power positive 9 times charge كمان سنة that is 40 times 10 to the power negative 9 باشا divided by the distance good man distance كت سنة 0.15 متر بس square أقل لي بس now if you do the math باشا math دكاتة سنة دكاتة 15,000 15,000 what 15,982 900 باشا 982.2 that is since it is electric field it is Newton per coulomb. That is electric field for the first charge. Now we're going to do the same thing for the second charge basha. So electric field of the second charge basically the same step basha. So we can say E2 for the second charge. Once again K coulombs constant this time the second charge ya كمان charge يكم is that charge دوما divide by the distance squared we can say basha got at the line 8.99 times 10 to the power 9 here times charge دوما got man 60 this time one yeah all right 60 times 10 to the power negative 9 divided by 0.15 squared basha. You could multiply this you could just wrote one, I mean, you could have multiplied this all together, then divide by 0.15, whether up or down here. What is the answer to this one equal to? It is equal to 23,973. 23,000, Basha. 973.3, I believe, right? Okay, that is what is it equal to. And now all they have to, once again, this is Newton per coulomb, Basha. Now, Gutman, these two electric fields are in opposite direction one, yeah, so we can erase this one. We no longer need this now. Man, these two electric fields are in opposite direction, but obviously one of the electric field that is stronger than the other electric field. So what do you think will happen now? Of course, Gutman, these two electric fields, or because these are in opposite direction, we subtract or we find the net at this point. Masha, Gutman, right at this point, kata the 20 blend electric field go to 3, or at this point the direction of the electric field is going to be to the other side. But right now, what I'm saying, if we don't prove that, it doesn't, like it has no value. So we can say the net electric field, Basha, we can say the net or the total. That's that baba. Dusht mane the 20 blend E1 minus E2, yan E2 minus E1, doesn't matter, Basha. But adatan, when we find the net electric field, we'll always do, like the second minus the first one. But if you do the second, we have a bigger value, and yeah. So if you say second one minus this one, you get a positive number, but at the end you'll have to say the direction of the electric field, it is toward Q1 أقال لي بباشا. So this is Q1 أقال لي بباشا أو Q1 أو education Q2. But if you say Q1 minus Q2, you get a negative value. What does a negative value means? That means it is going to be to opposite side or towards the negative x-axis, you can say. So it doesn't matter which one you want to do. Here, what I have done, I've done the second minus the first one. We'll say E2 minus E1 here, just like final minus, or the bigger minus smaller here. That is 2397 3.3 Basha minus the first one was 15,982.2 Basha. Now, of course, once you do the math, you will get something about 8,000. We can say 8,000 Newton per coulomb, or you could just say 8 times 10 to the power 3 Newton per coulomb. I believe you might not see this one, so I'll just write it up a little, Basha. So let me write it a little up. Gutman later, at this point here, we're just going to find the E net or the total Gutman E2 minus E1, Basha. But Gutman, E2 so the final direction is going to be at this point, it is going to be facing to the other side here because this two cancel out. Design the vector if two vectors are in the same direction, we add them. If they're in opposite direction, we subtract them. When this is what we're going to do here. Got a big minus small. Gutman, the second one, it is 2397 23,000 باشا 973.3 minus بتمان E يعني بابلين electric field هي كم was 15,982.2. So once you do the math here, you get almost like 8,000 Newton per coulomb, which you could just say 8 times 10 to the power 3 Newton per coulomb. بس قال لي بابا أو إستا direction چیه؟ direction بابلين E2 يعني بابلين electric field كواتا. You can either write this, but at the end you still have to say towards what? Towards Q1. This field is bigger كواتا. At this point it dominates يعني it is directed towards the smaller charge, which is Q1 at this point. أوش بسارتشي جوان بوباشا أغاتان لبي. Alright, we have this question as well. It says 2-point charges are a small distance apart. One of them is 4 times the second. Sketch the electrical field for the two. Yeah? So if both charges are positive, if the charges are positive, the field will be outward. But these are the two charges. One of them, it is 4 times stronger than the other one. Isn't that what it says? It says 4 times the other one. If one of the charge has one line, line need to be 4 lines. Because this is what it means. The electric field for this one is 4 times bigger than this. If this one has 2 line, need to be 4 times 2 أوقات دبيتا ثانية يعني جمارك هرت صندق بوبابا لير هرت صندق دنوسي أوقات دبيتا 4 times that much. Okay, do beat in 4 times 2, that'll be what? That'll be 8. So that is going to be 5, 6, 7, 8. Basha. What if this is 3, for example, here? Basha. Okay, if it is 3, this one is going to be 4 times 3, that is going to be 12. So this is going to be 9, or yes, 10, 11, and 12 here. But there is one thing I need you to know, Basha. It says these are both positive and there is a small distance apart. So if I draw one of the charges here, for example, these charges are going towards one another. So they're going to repel one another. So it is going to bend a little. This is how it is going to be, Basha. So now if this is 4, this one has to be 16. So let me draw this one maybe. Basha. Good man. This is, let's just draw 1 here. All right. We could draw even 2 if you want to. So that is 2, 3, 4. أقل لي 4 man heavy baba. أوديك 4 times as much. Got that is going to be 16. When yeah. Same charge. We could say just more fill lines here. So 1, 2, say 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. You can see that these fill lines are bending here. That means it is repelling. You could sketch something like that. What if both charges are negative? It's going to be exactly the same, but this time we're just going to do the arrows, let's say, inward. So you could exactly copy-paste this, but the only thing that is different now, the arrows are going to be inward here. So we did 4 times as much. 4 times that much is going to be 16. So got 16 more lines. 1, we could say 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and this is 16. It's supposed to be equal sign, but that's what I believe it is obvious enough because these are both negative, they're going to repel one another, so the fill lines will be bent because that indicates a repulsion sign. Interpreting data in this figure here, you see that, shows the electric field line for 2 charges separated by a small distance. Determine the ratio of Q1 over Q2. What does the ratio means? Division. When you Q1 is such here, is Q2. At this point, you have to start counting the lines. Count with me. Starting from this side here, we could say 1, 2, 3, 4, 5, 6, 7, 8, 9. When you got that for Q1, we have 9 lines. When you this is how you can count. That is 9. What about QT here? So you have to count all of it, by the way, even for those that are going here. So just because you counted these doesn't mean you don't count them, right? Because these aren't these lines coming out of this? Yeah, so you have to count everything now. So starting from, I don't know, like let's say this side here this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20. 21, 2, 3, 4. So this is 24. So over 24. Now you can simplify this, of course. That is going to be by 3, that by 3 is going to be 8, yeah? So we can say 3/8, and that is the ratio here. Now, the second part says, what are the signs of Q1 and Q2? Look, these are, or for this one, the arrows are inward. So Q1 must be what? Q1 must be negative. Q1 must be negative. What about Q2? It is outward. When you got that, must be positive. That's what you need to know. Sidi Kashman here, they'll explain why you're more likely to get a shock, all right, from static electricity by touching a metal object with your finger instead your entire hand, for example. Charges tend to or tries to accumulate more at sharper edges, Basha, because now your fingertips, of course, that is sharper than your whole hand, so charges accumulate more. This is why you get this annoying shocks because of electrostatic. All right, now more questions. Says how conductors differ from insulators. We've learned that conductors can conduct electrical charges. Why? Because they have free electrons. What about insulators? They do not conduct electrical charges easily because they lack free electrons. All right, more questions. I believe the rest of them are very easy. It says when a conductor is charged by induction, Basha, is the induced surface charge on the conductor is the same or opposite? Induction to Basha, if we bring a rod to a metal sphere, one side will become positive, negative when we earth the negative side so that these negatives will leave the surface. So eventually we'll end up with a positive sphere once we move the rod away. What is the charge, Basha? Let's say the charge on the conductor, is it going to be the same or opposite to the charge of the object inducing that? These charges the same or opposite to the rod? Of course it is opposite. The next part, a negatively charged balloon has this much coulomb of charge. How many excess electrons? How many excess electrons or how many electrons? What equation are you supposed to use? N stands for number of electron. The charge on the object divided by the charge of an electron. Negative it doesn't matter. It doesn't need to. 3.5 micro 10 to the power negative 6 one, yeah. And then divide by the charge of an electron 1.6 times 10 to the power negative 19. You do the math, of course, you'll get what? You'll get 2.19 times 10 to the power 13 electrons. This is how many electrons will be on an object that has 3.5 micro coulomb of charge. The balloon is negatively charged by rubbing and then clings to a wall. Does that mean the wall is a positively charged? No. If I draw this one here, the balloon is, if the balloon is negatively charged, the wall is basically neutral one, yeah. So it has positive, negative charges, positive, negative charges. The reason why these two can attract one another because these electrons are, of course, delocalized, you can say, one, yeah, by a process called polarization, one, yeah, negative right? But the negatives cannot move from one end to another. It can just swap or shift slightly so that these positive and negative are close to one another so that they can attract. No, the wall is not a conductor. The reason why it can attract it is because of polarization. Basha, this is the reason why. Okay, the last question that we have says, in which direction will the electric force, Basha, from the two equal positive charges move the negative charges as shown here? Basha, how does it move, Basha? This electron, of course, is going to be attracted by this two, so it is going to move to the left. What about protons? So the electron will be attracted to the left. You could just say to the left. To the left. And I believe that will be the end of this session. Inshallah, these are some standardized test preparation. Of course, it will be great if you practice them. Masha. Again, until question 6, then the rest you could give it a try. If you know, that is good. If not, you could just leave that. Masha, that'll be the end of our session. Inshallah, next time we're going to start with chapter 7. Till then, keep practicing and I'll see you soon. Inshallah. Assalamu alaikum wa rahmatullah.